Hi, in this video I'm going to do an example for kind of grade 12 calculus students, those who have introduced themselves into implicit differentiation. You can put up a link up above there. I did an introduction. Once you understand a little bit about implicit differentiation, you can use it to find derivatives, not just necessarily for functions. You can find it even for relations that you want to be able to find slopes at particular tangent points. So here is a pretty nice example of that. So it says find the equation of the line passing through the point, and it gives us the point on the circle. Now, you will recall that a circle is not a function, right? So it fails the vertical line test for us. And because of that, you might think that, well, how am I going to find derivatives here? So using implicit differentiation, you can do so rather quickly, okay, for something like this. Now we're going to be also plotting this circle, and I'll plot the line as well so that it nicely provides us a tangent point, okay, that you can visualize this through. So let's try this. They give us the point, so this shouldn't be too complicated, but the actual solution that we have, first thing that we would want to be able to do is, if we want to find the actual equation of a line, well, we need the actual slope at that point. And in order to do that, I would have to take this particular relationship of a circle. So this is a circle which I guess is centered at 0, and it has a radius of 3. So if you recall, okay, so circles have this particular relationship. So this is R, so R is the radius. That is if they are centered at 0. And for those who want to know, if you want to be able to try to center your line not necessarily at 0, so it will start to shift around, you're going to be running into this particular equation, okay, squared, and then R squared right there, where your circle is centered at this particular point. So X bar, Y bar, the way that I put it. And of course, you can also find derivatives of that if you wanted to. Now, so if I take this and I use implicit differentiation, I can do this term by term. So for instance, this is already with respect to X, so my derivative of that term is just 2X plus, now I need the derivative of this term. So because y, I'm going to assume that it's dependent on x, so this would have been 2y multiplied by, and this is going to be dy dx. This is the implicit differentiation. And then on the right-hand side, I just have a constant, so this is going to be 0. And with this, you can definitely find out what this is by just simply rearranging this equation. So that wouldn't be very difficult. Now, for us, it's actually specific because we want to know what the derivative is at this particular point. So you can just substitute those numbers in and then solve for dy dx. It would have been easier. Now, if I would generalize this and solve this, this would have been dy dx is equal to, so shift that, it's going to be negative 2x, and then divide by 2y. So this is, the 2's are going to be actually gone. Going to be negative x over y. That is the general, okay, slope, okay, or derivative with respect to dx. And notice it is dependent on x and on y within here. So that's pretty neat. Now we want to be able to, so I'm gonna, we draw a line like this. We want to be able to solve this at this point. So I can certainly do that. Well, that's going to be, I guess, negative 1 all over, and this is going to be the square root of 8. And that is my, I'm going to put m for slope of my line. And since they're asking us for the equation of the line, well, then that's not really difficult either, because y is equal to mx plus b. That's the equation of the line. We've just found the slope, so that's going to be that. We can substitute the point in here, so that's going to be 8, 1, and then we can solve for our b, or our y-intercept, so whatever that will be. So I guess this is going to be 8 Okay, whoops, what am I doing here? Square root of 8, I'm sorry. And then shift that over, so plus, this is going to be 1 over that. So that's my b. Yeah, so that's not going to be a very nice b, but I'll just keep it like this. All right, so you can certainly calculate it for yourself to a certain amount of decimal places if you wanted. I don't want to play with the decimal places. So my equation of a line is going to look very strange for you as a student. Plus, you know, and this is going to be square root of 8 plus 1 over 8 in this way. And that's the full equation of the line. And if you want to know and you want to take those square roots, you certainly can, but then you're going to have to start rounding those things off. So now it also asked us to plot this. So let's take a look and see. I'm going to plot it out in here. Let's maybe bring out decimals in here. I'll put it on the side. Okay, in this way. So my equation, so here's my circle. So x squared plus y squared. I am cheating because I'm using decimals. Of course, if you have to graph this on your own, you can do that as well. It'll be a little bit more work. And I guess this was 3 squared. So that's my, that's my circle there. The point, maybe let's put the point there as well. 1 and then square root of 8. Okay, so that will be that. Let's label it. There you have it. So it's 2.828. And then the square root, you can always find it. If you pop up the keyboard there, you can see that square root there. But if you write SQRT, then decimals actually converts and gives you that square root. So you can do that as well. And then my line was y is equal to, I guess this was -1 all over, square root of 8 and x. So that's my line plus, and I'll put it in brackets, square root. I'm actually being, very precise here because I am writing these things in here. So there you go. But that will give us a very nice exact point. So let me shift this out of the way. Okay, well, that's not my circle. I have to kind of, because if I'm zooming in, of course, the circles are not going to look like a circle, right? That's just because I just squashed the y-axis, so it has to be proportional. But there you have it. Okay, so there's my point. You can see the line, okay, which is attached that you have there to the circle, and you found what that derivative was. So that's actually pretty cool. So you can find the derivative, not just of functions, you can find it of relations as long as they exist within that particular relationship. So there you have it. So that was a nice little example for yourself to be able to see how implicit differentiation actually works. You don't have to isolate for y and then find derivatives. You can in some cases, but you can make your life a lot easier, as we did here, by implicit differentiation. All right, thanks for watching. We'll see you in a future video. Bye, everybody.